We'll use the Jamboard to show you the parts of a work order, much as we did for the parts of a purchase order. But a work order, again, in general, has at least three areas. One area, which is about the product and what's going on with this order itself, when it was made, which version of the work is supposed to be done, and what the product is. That's about the product. This is sort of about the production control area, like how many are required, how many are we asking for, how many were actually completed, how many of those were accepted and rejected. This is a big one that always shows up on there when cost accounting was involved. And then who's in charge of this thing? And then the green section is about the actual things to do themselves. So if I'm to put some sticky notes on here, one area is about the product, and another area is about this order. And then another area is the what to do. And we're going to take a look at each one of those a little bit. So here's the what to do, here's the about this order, and here's the about this product. So let's talk first about how do we signify which product we're going to work on. Well, in this case, we've got a description. What is it? The product number. That could be the assembly file number. It could be a master code number. Could be a product code. Any of those things that's describing to somebody what it is they're going to build. So, as an example, if they were building the inlet filter assembly, that's what this would be. The product description would be inlet filtered assembly. This would probably relate to the drawing. And the product code is something that if this is um, sort of grouped together with other things like this, it might be given a code. Okay. When did this get entered? Who wrote this down when? When did they write it down? And when do you need it? And that's pretty important because the planner can look and see whether that's reasonable or not based on the resources that are available. So if I entered this on today, 3/14/21, and said I wanted it 3/15/21 and I wanted 10 of them and it was going to take me more than 24 hours to do, that would be a little bit of a problem. And then this is always compared the date complete. When did it actually get done? So these are also used to track how productive the shop is. Okay, so that's one of the functions of a work order. It lets you track your productivity. Are you generally on time or are you generally late? And if a product is generally on time, but a certain worker is generally late, then the foreman or the shop lead gets a little upset, and so does accounting. So this is always in there, the date complete and the required date. Okay, so that's sort of about the product, sort of about the product. Sometimes this stuff is over here, but this is usually this product is generally on time or not. So now let's take a look at the section that's about this order. So how many are required and how many are on the work order? So if I need 100 of these, it could be that I only need to build 50 because I have 50 in stock. But this quantity required is always an important one to put in there. And then how many are on this work order? How many are you going to make? Right? That's really important. right? How many of these things do you need to make? That lets you know how much material to do, you know, how long it's going to take, things like that. And then when you're done, you want to know how many were completed. Let's say I wanted 50 and I completed 50, and then I go through an inspection and I only get 48 of them. Well, that leaves me too short. And it's very reasonable that there's a certain reject rate for a certain part. And so you want to keep track of that so that in the future you can up your work order number when you know that there's a certain number that always get rejected. So this is about production control, quality tracking, all that kind of stuff. And it's really important. It's not to say somebody did a bad job. Sometimes parts are just that way, that there is a reject rate depending on the process you go through. And so then that turns into a percent productivity. And I'm going to ask you all to um, leave some of this blank for now, but then we're going to work with these numbers later. And then the shop lead, who's in charge of making sure that this work order gets done and that these numbers are reported? That's also really, really important because sometimes there's just questions. Okay. Was that reject capable of being fixed? Did it harm us in the end? Was it no big deal? There's all sorts of things like that that can happen. And the shop lead is the person who knows most about it. So there's the about this order section. And, you know, as with purchase orders, everybody's got their own work orders. Okay. We even had different work orders for different products in one of the shops that I worked in. So these are just general things to think about. You have to know about the product, you have to know about this order, and then you have to know what to do. And we'll talk about this one a little bit more later as we get into the examples. But there's an operation, and that operation is to do something. And sometimes this is long and sometimes it's short. But maybe the operation is 3D print, remove, clean, inspect, something like that. There's some series of things that gets done, and they are not necessarily exact. Like on the, if I asked you to mill something here, you wouldn't have to say your whole milling plan. You would just say milling operations. The work center ID, now for us, it's all going to just be one. It's going to be the shop. But some shops have an ID for the mill, and it might go from the mill to the part cleaner to inspection, and those would all have different work order IDs. And then some places, everything's all just lumped into one. So we're going to sort of ignore work center ID other than this brief description. Then there's a description of what you want to do. Okay, what do you want to do? Mill the part, manufacture the part, what drill holes, whatever it is you're going to do. All right, and then look, there's a labor hour for each one. Okay, labor hour for each one. Somebody else will work about calculating all these things and multiplying it by how many there are over here and over here and over here. Somebody else will do all that calculation. Sometimes that's on the work order, and sometimes it's not. Sometimes there's um, another column for total hours. But we're going to go the labor hours for each one of these operations. But we are going to track how many came into that operation and how many got out and how many were rejected and who did that inspection. All right, so this is really keeping track. This is keeping track of what's going on so that you can answer these questions. This is keeping track so that you can multiply it by how many this quantity in is to get your total quantity and your total time. Okay. And so you can imagine if I started out with 50 and I had 50 come in and I had 48 come out, and then I had 48, 48, 48, 48, 48, 48. then I'd know that this is the operation if I was going to fix something up that I could do something. So this what to do segment has a lot of stuff in it. It has literally what is the name that you're calling what you're doing, where is it done, a more detailed description, how long it's going to take, and then what was the success rate and who was the person operating. Then if there are inspection requirements, they get listed here. And of course, you're going to have to call out the reference drawings and the files. Sometimes there's more than one of those. As an example, if this was the milling operation on that block, you would have the number for the block and you would have your CNC file that you would be using to measure or to operate it with. So any reference drawings or files, they all get listed right here. So those are the parts of a work order. And for your assignment, you'll expected to do something kind of like what I just did. Some sort of annotation that lets people know about this.